Hey class, we're going to review all the solving methods. We've done a lot of different ways to solve quadratics, so I just want to kind of summarize it all and review. So all solving methods. So first thing we solved was solved using square roots. Solve by square roots is all about isolating the part that has the square. So either isolating the x squared or the parenthesis that is being squared, and then taking the square root of both sides. So for this one, I'm going to start by getting this x squared by itself, so getting rid of the 3, so subtracting 3 from both sides because it's a positive 3. That's going to leave me with a negative 5x squared. Negative 9 and negative 3 is negative 12. Then I'm going to divide both sides by negative 5. I'm going to get x squared. I can't divide 12 by 5, so that's going to be just 12/5. And then we take the square root of both sides. When you square root a fraction, you take the square root of the top and the bottom separately. So we're going to get x equals plus or minus the square root of 12. I can reduce that. Oops, my dad's calling me. I'll have to call him back. Square root of 12 is 4 and 3, and then 2 and 2. So 2 square roots of 3, and then we can't reduce the square root of 5, so it's the square root of 5. Now, technically, that's the correct answer. However, if we want to be in the right form, we're not supposed to leave square roots on the bottom. So we're supposed to do what's called rationalizing the denominator. And we didn't talk a whole lot about this. So if you got that far, that's great. But rationalizing would say you got to get rid of the square root of the 5. So you would multiply both the top and bottom by the square root of 5. And your answer would then be plus or minus. You'd have 2 times 1 is 2. And then the square root of 3 times the square root of 5 is the square root of 15. And then the square root of 5 times the square root of 5 is the square root of 25, which just simplifies to 5. So it's just another way of rewriting it to make it a rationalize the denominator. Okay, for this one, you want to leave the parentheses. Don't multiply it out. You can't distribute into it because it's being squared. So just get it by itself. So you got to get rid of this negative 3. So you're going to divide both sides by negative 3. You're going to get x minus 2 squared equals negative 7. Then square root both sides. And x minus 2 equals the square root of negative 7 is going to be plus or minus I square roots of 7. So the negative 1 comes out as the I. Square root of 7 is irrational, so you leave it as the square root of 7. Then we add 2. And since we have a real number here along with a imaginary number, our answer is a complex number. It's going to be 2 plus or minus I square roots of 7, which is 2 plus I square roots of 7 and 2 minus I square roots of 7. So both answers there. All right, then we solved by factoring. So solve by factoring, you want to get it as factors. So like a times b equals 0. Then you set each factor equal to 0 and solve further for x. Because the zero product property says that if a times b is 0, then either a is 0 or b is 0, or they're both 0. So anything times 0 is 0, essentially. So here we have 2 terms, so I'm not going to, if I have 2 terms, typically you're not using the box. You're looking for a greatest common factor or difference of perfect squares. 3 and 18 aren't perfect squares, but I can take out a 3, and I can take out an x. So if I take out a 3x here, I'm going to be dividing both of these by 3x, so I'm going to be left with an x minus 18 divided by 3 is 6, and the x's both come out there. Now I'm left with a single x, so you can't go any further. So then set each factor equal to 0. So 3x either equals 0 or x minus 6 equals 0, and then solve. So this one, divide both sides by 3, x equals 0. This one, add 6, x equals 6. So those are your 2 answers for that one. For our part B here, solve by factoring, since you're using the zero product property to solve by factoring, you do have to have it equal to 0. So, and your leading coefficient, the x squared, has to be positive. So if you subtracted the x squared and the negative 10 over, then you would have had to divide everything by -1 before you started. So instead, I'm going to move this way. So I'm going to subtract 3x, and then I'm going to add 6. Okay, so that gets rid of this on the other side is 0. Now, there's nothing to combine with the x squared, so x squared. The negative 3x that goes with any other x's, and there is none, so just minus 3x, and then minus 10 plus 6 is minus 4. Since this is just x squared, it'll factor to x times x. So you need to find two numbers that multiply to -4. A times c is -4, adds up to b, which is -3. So multiplies to -4 and adds up to 3, that'd be -4 and +1. Since it's x squared, these will be your factors, x minus 4 and x plus 1. If it's not x squared, then you do need to do a little bit more work and use the box. But we've reviewed that again, so hopefully you're feeling good about that. So then x minus 4 equals 0, or x plus 1 equals 0 means that if you solve this one, either mental math or add 4 to both sides, x equals 4. If you solve this one, you subtract 1 on both sides, x equals -1. So those are your two answers there. And if you think back to graphing from vertex form, graphing the parabola, this is the x-intercepts. The zeros, the solutions, the roots, they're all connected there. Quadratic formula. So first, remember the discriminant is the b squared minus 4ac part, and that tells us how many solutions it's going to have and what type of solutions. So this is my a, my b, and my c. So to find b squared minus 4ac, I'm going to say this is -2 squared minus 4 times a times c. Since there's only one subtraction here, it's going to be minus, and -2 squared is 4, and then it'll be minus 4 times 3 times 1 is 12, which will be -8, which means it will have two imaginary solutions. The quadratic formula is x equals -b plus and minus square root b squared minus 4ac all over 2a. So x equals -b. b is already -2, so negative 2 is going to be +2. Plus or minus the square root, the discriminant, b squared minus 4ac, I got -8, so that's what goes there, over 2 times a, which would be 6. So we do need to reduce this a little bit. So the square root of -8 can break that down. It's 4 times 2 and 2 times 2, so I can take out a 2, and it's negative, so I'm going to take out a 2i. So we're going to have 2 plus or minus 2i square roots. This 2 is left in there. And then 2 times 3 on the bottom was 6. Now all my coefficients are even, so you can reduce that one more time by dividing each of those coefficients by 2. So 1 plus or minus I square roots of 2 over 3, or 1i square roots of 2 over 3. All right, then we did complete the square. So complete the square. First step, a had to be equal to 1, which it is not. We have a 3x squared, so I'm going to divide everything by 3. Then I get x squared plus 3 equals 2x. Then we had to have it as c by itself. So we want x squared plus bx equals c. So that means that I'm going to have to subtract 3 on both sides, but you're also going to have to subtract 2x over here. So you move the x to the left. So you're going to be x squared minus 2x. And then I'm going to add plus blank equals -3 plus blank. At this step, you're looking to complete the square. So to complete the square, you take half of your middle term. So you take your b term, divide it by 2, and you square it. So that in this case, it'd be -2 divided by 2, and that'd be -1 squared would be +1. You add that to both sides to keep the equation balanced. Then you factor it, so you get something squared. It always factors to x plus whatever your b divided by 2 was. So in this one, it was -1, so it'll be x plus -1 or x minus 1. Because when you multiply this back out, -1 times -1 is 1, -1 plus -1 is -2, equals -3 plus 1 is -2 on this side. Then we take the square root of both sides, and we finish solving. X minus 1 equals plus or minus. The square root of -2 would be I square roots of 2. Add 1, and we get 1 plus or minus I square roots of 2. Since it is our answer is complex number, real and imaginary, we leave it like that. If we had two integers, like 1 plus or minus 2, we would say that our answers, remember, if it's 1 plus or minus 2, then our answers are 3 and -1, because we would combine those. If it is 1 plus or minus the square root of 2, you can leave it. If it's a real and imaginary, you leave it. So you only combine them if they're both integers, and you can combine like terms then. I'm just going to do one more, solve by complete the square. This one is where you end up with fractions. So it's kind of a messier one. I just wanted to review it. Make sure we had it down. So a has to be equal to 1. So divide everything by -6 in this case. It'd be x squared minus 1x minus, that'd be a half, equals 0. Move the half to the other side. So I'm going to add my plus blanks. So I moved it to over here by adding a half to each side. Then take half of your middle term and square it. So that'd be -1 divided by 2 squared, which would be 1/4 to both sides, because -1 squared is 1, 2 squared is 4, or it's 1/2 times 1/2, which is 1/4. So you multiply it across the top and across the bottom. Then you factor it. It's going to be whatever this was. So it'll factor to x minus a half squared. Remember, if this is negative, this is negative. If this part here is positive, then your parenthesis would have a positive number as well. 1/2 times a fourth, you do need a common denominator. So 1/2 is 2/4 plus 1/4. You just get fourths by multiplying both the top and bottom by 2. And so that equals 3/4. Then when we take the square root, we square root the fraction, the top and bottom separately. So it'll be x minus a half equals plus or minus the square root of 3 is just the square root of 3. It's a decimal, 1.7 something, over the square root of 4 is 2. Then add a half to both sides, and I will accept the answer as 1/2 plus or minus the square root of 3 over 2. Technically, since these do have the same denominator, you could say it's 1 plus or minus the square root of 3 all over 2 if you wanted to add them together. So either one is just fine. Hopefully that was a good review lesson, and you got the solving stuff under control. If I say solve by whatever method, you can do it. Give it a shot. I didn't tell you which method to use. I said method of your choice. So, quadratic formula works every time. If it's in standard form. Complete the square works really nice if your b, the middle one, is even or divides out evenly. And complete this or solve by square roots works really nice if you have a parenthesis or you have no middle term, no x term. So you decide which method works best for you for each of these. Thanks for watching.